The Meiduo 28A transistor radio made news portable. Turn its tuning control and the antenna circuit selected a station. A local oscillator and mixer shifted that station to a fixed intermediate frequency. Amplifier stages strengthened it. A detector recovered the audio, and a final stage drove the loudspeaker. 8 transistor triodes, 1 diode, batteries, and a printed circuit board put this complete receiver in a handled case instead of a piece of living room furniture. The exact product matters. People's Daily's account, published by the All China Federation of Industry and Commerce with evidence from the Shanghai Radio Museum, records that Shanghai Radio Factory No. 3 and component factories completed the Meiduo 28A in September 1962, and put it into production in October. It identifies the set as a portable medium and shortwave superheterodyne receiver made with domestic components. The case measured 235 by 137 by 65 mm, and the radio weighed 1.36 kilograms with its battery. Those are documented specifications, not estimates from a surviving photograph. This was one stage in a sequence, not a single miraculous first. A Shanghai team completed a 7-transistor portable prototype in March 1958, using imported active devices. Later that year, Shanghai-made germanium diodes and transistors became available. In 1959, 300 Meiduo 872 1-1 receivers reached the market, making that model the account's first commercialized Chinese transistor radio. The 28A then joined domestic small components, a printed circuit board, a plastic case, 2 wave bands, and an assembly line. Its importance is therefore repeatable manufacture, not merely a laboratory demonstration. The solid-state change can be described without pretending that one part did everything. A transistor controls a larger current with a smaller electrical input, so it can amplify a weak signal or sustain an oscillator. The Computer History Museum documents early germanium point contact transistors and their rapid replacement by more reproducible junction devices. That broader history explains the engineering direction, but it does not identify the precise construction of every transistor inside the 28A. The verified product claim is narrower. Shanghai sources describe domestic germanium devices, 8 transistor triodes, 1 diode, and a superheterodyne circuit. Removing heated filaments reduced power demand and warm-up requirements, while the small solid-state parts made a compact printed board layout practical. The radio still required tuned coils, capacitors, a speaker, careful alignment, and battery energy. The transistor enabled portability but did not create it alone. Even the phrase first Chinese transistor radio needs care. The Communication University of China Media Museum records the Songhuajiang 601, completed in Harbin in September 1958, as an early 7-transistor superheterodyne assembled with self-made components and later produced in small numbers. The Shanghai sources use different milestones: first prototype, first Shanghai-made semiconductor devices, first commercialization, first all-domestic portable set, and first production line. Keeping those categories separate prevents a dramatic title from erasing the actual industrial process. The Meiduo 28A represents the moment a network of factories could reproduce portable radio as a product. Portability changed the listening routine before it changed the program. A valve receiver normally asked the listener to come to a fixed cabinet, connect reliable power or manage large batteries, wait for heated cathodes, and share the sound with whoever occupied the room. A battery transistor set could be carried to another room, a workplace, a courtyard, or a journey. The Meiduo 28A was not pocket-sized, and the sources do not show that every household owned one. Its handle, low-voltage solid-state circuit, and 1.36 kilogram operating weight nevertheless altered the practical boundary. The receiver could travel with the listener instead of defining one listening place. The superheterodyne chain explains why the set could find many stations with one tuning control. The tuned input favored the selected broadcast frequency. A local oscillator changed with the dial, and the mixer combined its signal with the incoming carrier to produce a fixed intermediate frequency. NASA's technical description of the architecture identifies the same core elements: local oscillator, mixer, filter, and intermediate frequency amplifier, working at one fixed frequency. Let later stages be optimized for selectivity and gain. The detector separated the audio information from the radio frequency carrier, and audio amplification supplied enough power for the speaker. Transistors performed amplification and oscillation without heated valve filaments. The 28A depended on an industrial system larger than its case. The official history names Shanghai Radio Factory No. 3, Shanghai Component Factory No. 5, and other component makers in the development effort. Domestic germanium devices alone were not enough. Resistors, capacitors, coils, loudspeaker, switches, battery contacts, printed board, molded case, assembly fixtures, testing procedures, and repair knowledge had to agree. The first production line described by the source made repeatability visible. Workers needed to assemble and align receivers so the tuning scale, intermediate frequency stages, and audio output behaved consistently. Portability was therefore a property of coordinated manufacturing as much as of the transistor itself. Early solid-state manufacture also imposed costs. People's Daily's account says the 28A cost 192.83 yuan to make, while its approved retail price was 160 yuan, with the difference subsidized, and connects that mismatch to low yields among domestic miniature components. Those figures belong to this model and production moment. They should not be generalized to every radio. They reveal the economic gap between proving that domestic parts could work and producing them cheaply and consistently. A smaller, lower power receiver could still be expensive when many components failed inspection. Industrial learning reduced that burden over time, while wider production created more opportunities to improve parts, alignment, assembly, and service. A portable radio rearranged who could choose the listening place, but it did not automatically make listening private. The 28A retained a loudspeaker, so a carried set could still gather a group around one broadcast. Its two bands also joined different scales of reception in one object: medium wave for available broadcasts and short wave where conditions and stations permitted. The accurate social claim is modest. Moving the receiver removed the fixed cabinet as a condition of access. It allowed news, speech, music, and other broadcasts to enter spaces that a furniture-sized set served poorly. The source-supported contradiction is strong enough without inventing a family anecdote. The information remained transmitted from distant stations, while the receiving object became physically local and movable. The standalone transistor radio did not vanish on one date. Shanghai Observer traces a succession from discrete germanium transistors to integrated circuits, cassette radio combinations, digital tuning, and radio functions inside other products. Television took over many scheduled visual events. Cassette machines added recording and personally chosen playback. Later portable players and phones separated audio from the broadcast schedule, while Internet audio expanded the catalog further. Each replacement changed a different part of the bargain. The 28A's core service, receiving live wireless audio, survived, but the dedicated case no longer needed to carry every function by itself. Survival shows why radio and Internet audio are not identical. A broadcast receiver can work without a subscription or a return data connection, provided it has power, a usable antenna, and a receivable signal. Shanghai Observer notes that radios can remain useful when networks or grid service fail, though that general observation does not establish performance in every emergency. The object also survives among collectors and in specialized receivers. These exceptions do not mean the 28A remained technically current. They show that one-way broadcast, simple local controls, replaceable batteries, and a loudspeaker can still form a rational package where low infrastructure dependence matters more than search, recording, or personalization. The Meiduo 28A's lasting idea is portable access to a remote information system. Its germanium devices were later displaced by silicon and integrated circuits. Analog tuning could give way to synthesized controls, and the radio function could shrink into a car dashboard, phone, or single chip. Yet the design expectation remained: Information should reach the user wherever the user happens to be. The 28A did not create broadcasting or invent the transistor. It joined domestic components, superheterodyne architecture, batteries, a printed board, a speaker, and repeatable factory assembly into one carried receiver. That shift made the radio a carried appliance, not fixed furniture. The precise achievement is more revealing than a vague claim that radio changed China overnight.